So hello, good morning everyone. My name is Sir Eldon Akain. I'm your math teacher. In this lesson, you're gonna learn about the probability of simple events. Our learning competency states that we should find the probability of simple event. Now, what is the importance of probability in real life situation? How can you apply probability in real life situation? Now, you can apply this in different ways. Number one, a candidate for election would like to know his possibility of winning the election. So in this case, a politician will evaluate his probability of winning the election. So he will be using probability. Next, a businessman may know the product preference of people in a certain place. So let's say, for example, a businessman would like to establish a business in Pangasinan. Will have to know the product preference of people in that certain place in which he would like to establish his or her business. Number 3, probability of getting head when a coin is tossed. Now you will be able to know the probability of getting ahead when you tossed a coin. And number 4, knowing the in-demand job abroad. Now, if you're a person looking for an in-demand job abroad, you are most likely using probability. Now, what can you say about the following situation? We have here impossible, unlikely, even chance, likely, and certain. Now, impossible means you have no possibility at all. Unlikely means you have a small possibility. Even chance means you have equal chance. Likely means it is more possible to happen, and certain means it will surely happen. Now I will give you situations. Number 1, to live forever on earth. What can you say about this statement? Is it impossible, unlikely, even chance, likely, or certain? Very good. So the answer is it is impossible, because it is impossible for you to live on earth forever. Number 2, win in a lotto draw. Is it impossible, unlikely, even chance, likely, or certain? Very good. It is unlikely, because you still have a possibility of winning the lotto draw, but unfortunately it is unlikely. Number 3, probability of getting ahead when you toss a coin. Is it impossible, unlikely, even chance, likely, or certain? Very good. So the answer is even chance, because you have equal chance of getting either head or tail. Number 4, becoming a good student. Is it impossible, unlikely, even chance, likely, or certain? Very good. Becoming a good student is likely to happen. Number 5, the sun will rise again. Is it impossible, unlikely, even chance, likely, or certain? Very good, that is certain, because surely tomorrow the sun will rise again. So it is 100% probability that the sun will rise again. So again, our topic is all about probability. What is probability? Probability is the mathematical term for the likelihood that something will occur, such as drawing an ace from a deck of cards, or picking a green piece of candy from a bag of assorted colors. We have here the terms sample space, events, and probability. Event is one outcome or a collection of outcomes, while sample space is the number of all the possible outcomes in an experiment. The probability of an event is the ratio that compares the number of favorable outcomes to the number of possible outcomes. Our formula for getting the probability of a certain event is P equals E over S, where E stands for the number of outcomes an event can occur, and S is the number of possible outcomes that an event could occur. So let us have an example of probability problem. So we have example number 1. When you toss a coin once, what is the probability that it will land head? So in this example, we are looking for the probability of getting a head when you toss a certain coin. So we will represent it using P of H. And getting a head means there are two outcomes, head and tail. And we are looking for head only. So that is 1 over the two possible outcomes. So our answer is 1 over 2. It means that the sample spaces of this given problem is H and T, and E is the event. So our answer is 1/2. Let us have another example. A pair die is tossed once. What is the probability of getting an even number? So we have a certain die here. Now let me remind you that die is the singular form of dice. So we are looking for the probability of getting even numbers. And what are the even numbers found in a die? We have 2, 4, and 6. But we have 6 spaces here, numbered 1, 2, 3, 4, 5, and 6. So the probability of getting an even number from a certain die is P equals to 3 over 6. Meaning there are 3 even numbers, and that is 2, 4, and 6. And we have 6 possible outcomes in this given experiment. So our answer is 3 over 6. And we can reduce this term if we divide both the numerator and the denominator by 3. So we have P equal to 1/2, and that is our answer. The sample spaces is S equal to 1, 2, 3, 4, 5, and 6. So meaning these are all the possible outcomes in this given experiment. But what we are trying to look for is the probability of getting 2, 4, and 6. And that is the event, which can be described in words as even. Now let us have the third example. In tossing a coin twice, what is the probability of getting 2 heads? So in this experiment, we will be using 2 coins. So our P is P2H. So what are all the possible outcomes of this given experiment when you toss 2 coins? So one is head and head, or H and H. Next is head and tail. Next is tail and head. Next is tail and tail. So we have 4 possible outcomes. Now what we are looking for is the probability of getting 2 heads, and that is HH. So there is only 1 probability of getting head-head out of 4. So we have 1 over 4, and that is our answer. The sample space is S equal to HH, HT, TH, and TT, which means head-head, head-tail, tail-head, and tail-tail. And our E is head-head. So meaning there is only 1 possibility of getting head-head out of 4. So our answer is 1 over 4. Now you have now learned how to find the probability of a certain event. So now let us have a quiz. So this is your quiz. Given a spinner on the figure, determine the probability of spinning. Number 1, probability of getting red. Number 2, probability of getting green. And number 3, probability of getting blue. I will give you 5 minutes to answer these questions, and you have to pause this video for a while, and then later on you will see if you got the correct answer. So your quiz starts now. So after 5 minutes, you have to play this video and you will know the answer to the given quiz I have given to you. So number 1, the answer is 1/4, because there is only 1 red in the given figure and there are 4 possible outcomes. The possibility of getting green in number 2 is also 1/4, because there is only 1 green out of 4 possible outcomes. And number 3 1 over 4 again, because there is only one blue out of 4 colors. So that is the answer. Okay, I want you to answer this problem. One card is randomly drawn from a standard deck of playing cards. What is the probability that the card drawn is letter A? Probability that you will get diamond. Letter B. Probability that you will get 5. Letter C. Probability that you will get 2 hearts. And letter D. Probability of getting ace. So pause this video for a while, then later on I will tell you the answer to this given problem. So your quiz will start now. Pause this video for a while. Now, after 5 minutes, I will tell you the answer to this given question. Now, before anything else, I would like you to know that there are 52 cards in a standard deck of playing cards. There are 13 hearts, there are 13 spades, there are 13 flowers, there are 13 diamonds, okay? So all the possible outcomes is 52. So what you will put in the denominator is 52. So getting a diamond, remember that there are 13 diamonds in a standard deck of playing card. So our answer in letter A is 13 over 52, and you can reduce that. Letter B, there are 4 5s in a standard deck of playing card. What is the probability of getting 2 of heart in letter C? So there is only one 2 of heart out of 52, so our answer is 1 over 52. How about getting an ace or the letter A in a standard deck of playing card in letter D? So there are 4 letter A in a standard deck of playing card. So our answer is 4 over 52, and you can still reduce that. So this is our topic about the probability. So this is our topic about knowing the probability of simple events. I hope you learned something from our discussion. So this is your teacher, Sir Eldon Akain, saying have a nice day everyone.